In this mini lecture we will discuss the science behind global climate change and current and future impacts of climate change. After reading Chapter 18, watching this video or reading the transcripts that go with this video, and watching the other assigned videos and activities for this chapter, you should be able to describe Earth's climate system and explain the factors influencing global climate, characterize human influences on the atmosphere and on climate, summarize how researchers study climate, outline current and future trends and impacts of global climate change, suggest ways we may respond to climate change. Global climate change is a subject we could spend an entire semester. It is a Herculean task to try to discuss the subject in 1 week, or even half of a week. Therefore I am devoting this week to just Chapter 18. In this video mini lecture we will not go into the Earth's climate system, rather I have posted a video in the Chapter 18 Concept Videos folder that explains this very well. The video is a narrated and captioned video and is titled, "How Does the Climate System Work?" This video explains how the Earth's climate system works, the natural greenhouse effect, the effect of the tilt of the Earth on the climate and weather patterns, large-scale circulation systems, the role of the ocean in climate. Please watch this video this week. There another video in this folder titled, Our Atmosphere and Human Activity, which is a video lesson that examines the formation of the ozone hole and the factors that influence global warming. It also discusses the effect of human activity on the atmosphere by analyzing data. Please watch this video this week as well. There are several other videos in this folder I think you would find very informative and helpful for this chapter. However, I am not requiring that you watch these videos. They are optional and may help you better understand the principles in the chapter. People often confuse and misuse the terms global change, global climate change, and global warming. You should understand the subtle, but important, differences between these terms. To begin, global change is the change in the chemical, biological, and physical properties of Earth. Examples of global change include rising sea levels, decreased biodiversity, over-harvesting or exploitation of plants and animals, and global climate change. Notice that global climate change is just one type of global change. Global climate change is quite simply changes in Earth's climate. These changes include stronger storms, altered patterns of precipitation and temperature, changes in patterns of ocean circulation, and global warming. Again, notice that global warming is just one of the many types of global change. Global warming is the increase of the Earth's average temperature. Examples of global warming include warming of the Earth's land, air, and water, increases in occurrences of heat waves, and decreases in occurrences and duration of cold spells. The take-home point from all of this is that global warming and climate change are not synonymous. Understanding climate change requires understanding how our planet's climate works. For this reason it is important that you read the full chapter, and if you still need additional clarification, watch the videos I mentioned that are in the Chapter 18 Concept Videos folder. In addition to understanding how Earth's climate works, you also need a complete understanding of the greenhouse effect. This image illustrates this concept well. The sun emits solar radiation, which travels through space to reach our planet. The Earth absorbs about 70% of the solar radiation it receives. The radiation that is not absorbed may be absorbed by the atmosphere, reflected by the clouds or aerosols in the atmosphere, or is reflected by the Earth's surface. Yellow arrows in this figure represent the energy from the sun. The radiation absorbed by the surface of the Earth is re-emitted. It is very important to note that incoming solar radiation is energy with a shorter wavelength compared to the infrared radiation that is re-emitted by the Earth. This is why the solar radiation is referred to as shorter wavelength radiation, and the infrared radiation re-emitted by the Earth after absorbing the solar radiation is referred to as longer wavelength radiation. After the longer wavelength infrared radiation is re-emitted by the Earth, gases in the atmosphere absorb some of this radiation and re-emit it. This causes some of the infrared radiation to warm the lower atmosphere, i.e. the troposphere, and some to warm the surface of the Earth. That radiation is then sent back to Earth. This is the greenhouse effect. The greenhouse effect is a natural. Without it our planet would be much colder and possibly uninhabitable. However, we have exacerbated the greenhouse effect by adding large quantities of infrared trapping gases to the atmosphere. These gases are called greenhouse gases and include water vapor, H2O, tropospheric ozone, O3, carbon dioxide, CO2, methane, C4, nitrous oxide, N2O, and halocarbons, such as CFCs. Not all of the previously mentioned greenhouse gases contribute equally towards the greenhouse effect. This is a table that illustrates the relative heat-trapping capacities of 4 of the greenhouse gases. The values shown on the right of the table are expressed in relation to carbon dioxide, or in other words, how many carbon dioxide molecules would it take to equal the heat-trapping capacity of various greenhouse gases. As you can see, nitrous oxide is 298 times more potent than carbon dioxide. This table might be confusing because most people associate carbon dioxide as the main culprit of the greenhouse effect, but this table suggests that carbon dioxide isn't as potent in terms of trapping heat as methane, nitrous oxide, or hydrocarbons. While this is true about the potency of carbon dioxide, what is also true is that carbon dioxide is far more abundant than any of the other gases listed here. Carbon dioxide also has a longer residency time than methane. For this reason, carbon dioxide contributes more to the greenhouse effect than the other, more potent, gases. Specifically, CO2 is causing 6 times more warming than methane, nitrous oxide, and halocarbons combined. You're probably aware that many of the greenhouse gases are added to the atmosphere by the burning of fossil fuels. Since the start of the Industrial Revolution, which spanned from approximately 1760 to 1840, the global concentration of CO2, methane, and nitrous oxide have increased at an exponential rate. While it is true most greenhouse gases have been in our atmosphere for all of Earth's history, we have intensified the greenhouse effect by increasing the concentrations of several natural gases over the last 250 years. Halocarbons are entirely synthetic and are only in the atmosphere because of our actions. The main cause of an increase in the amount of carbon dioxide in the atmosphere is because we are burning fossil fuels, which releases carbon stored in the lithosphere and emits it into the atmosphere. The secondary cause is deforestation, which removes the forest as a reservoir for storing carbon and eliminates the organisms that are able to absorb, store and use carbon dioxide. Methane concentrations have risen because of fossil fuel combustion and large-scale livestock production. Nitrous oxide is released as a byproduct of feedlots, chemical manufacturing plants, vehicle emissions, and synthetic fertilizers. Ozone concentrations in the troposphere have risen because of photochemical smog. Halocarbons also contribute to global climate change, however their contribution has lessened due to the Montreal Protocol and the subsequent international agreement to control the production and use of these gases. Water vapor is a naturally occurring gas and contributes to the naturally occurring greenhouse effect, however because its concentration hasn't changed it is not associated with driving climate change. Scientists study climate change by using proxy indicators to study what the Earth's climate was like in the ancient past. The climate of the ancient past, or paleoclimate, is essential for studying climate change because it gives us a baseline against which we can measure changes occurring in our climate in present day. Proxy indicators are types of indirect evidence that serve as proxies, or substitutes, for direct measurements. Ice cores are a very common proxy indicator used by climate scientists. Bubbles trapped in the ice contain samples of the air from thousands of years ago. The ice is layered over time, so by studying ice cores we can determine the atmospheric composition, greenhouse gas concentration, temperature trends, snowfall, solar activity, and even the frequency of forest fires and volcanic eruptions. The image in the bottom right is an image from a video that shows the concentration of CO2 in the atmosphere from 800,000 years ago to present day. This video is in the Mini Lectures, Presentations, and Videos for Week 11 folder and is titled NOAA Trends in Atmospheric Carbon Dioxide. This video is a great visual of how carbon dioxide concentrations in the atmosphere have changed over time and dramatically increased since the Industrial Revolution. The evidence of climate change is all around us. In the Mini Lectures, Presentations, and videos for week 11 folder you will find a video that shows the Maldives government holding a cabinet meeting underwater to draw national attention to the plight their country faces due to rising sea levels, longer heat waves, more intense storms and droughts, and increases in flooding are all indicators of global climate change. What is important to keep in mind though is that we cannot blame any single weather event on climate change. However, it is the patterns that have been observed that matter. The scientific body that gathers the data on these patterns, reviews, and summaries the climate change information is the Intergovernmental Panel on Climate Change, IPCC. Their reports are composed from peer-reviewed studies completed by hundreds of international scientists. Additionally, government reports are also used in IPCC reports. Climate change data indicates that average surface temperatures increased 1.33 degrees Fahrenheit from 1906-2005, that most of the increase occurred in the last few decades. The 17 warmest years on record have been since 1990, that 2001-2010 was the hottest decade on record, and that since the 1960s, each decade has been warmer than the last in terms of precipitation. Climate models indicate precipitation will increase at high latitudes and decrease at low and middle latitudes, which will exacerbate existing water shortages in poor nations. Another documented effect of global climate change is the melting of mountain-top glaciers, snow cover, ice sheets, and sea ice. The melting of global ice is most pronounced in the Arctic. As glaciers melt, additional fresh water is added to the sea, causing sea levels to rise. 77% of the country of Maldives is predicted to be underwater by the end of the century if the pattern of warming and sea level rise continue at their current rate. A recent study indicates that we can expect sea levels to rise 2.5 to 6.5 feet by 2100. While the Maldives is a far-off country that may not mean much to you, Florida is not. These projections would make Miami either a city by the sea or city in the sea, depending on how high within the project range sea levels rise. As sea levels rise and oceans expand because they are warmer, this will lead to beach erosion, coastal floods, intrusion of salt water into aquifers, and stronger storm surges. Global warming also threatened both aquatic and terrestrial animals. Warmer oceans are detrimental to coral reefs, mangrove forests, and salt marshes. Coral bleaching is suspected to be due in part to warmer ocean water. Ocean acidification is another detrimental global change. The ocean has become more acidic because it absorbs CO2 from the atmosphere. This change in pH is detrimental to ocean life in that it impairs the ability of corals and other organisms to build their exoskeletons. Terrestrial animals and plants are also at risk. Humans have the ability to adapt our homes more easily than animals. We could just turn up the AC. But animals don't have that luxury. Many bird species have shifted their ranges northward in the past 40 years due to warming temperatures. Animals and plants adapted to mountain environments will be forced uphill, but at some point the birds can't fly any further north and the animals on a mountainside can't go any higher up the mountain. Plants are at an even greater disadvantage because they have far less mobility compared to animals. Their best hope is that their seeds will be transported to an area with slightly more suitable conditions. Global climate change is expected to threaten 20–30% of species with extinction. Society is already feeling impacts of climate change. Climate change-induced water shortages, droughts, changes in precipitation, more intense storms, and altered growing seasons are all happening right now. Unfortunately, like many other environmental problems, the people living on the fringes of society and in the depths of poverty are the ones that will be affected the most by the effects of climate change. There are several climate change effects that have occurred, are occurring, and predicted to occur that will have significant impacts on society. Some of the more prominent effects will be seen in agriculture, public health, economics, and forestry. In regard to agriculture, farmers already have to adjust their techniques and schedule to accommodate the altered growing cycle. It is predicted that in temperate zones the growing season will be lengthened, which would cause a slight increase in production. On the other hand though, the seasonally dry tropic and subtropic zones are expected to experience shorter growing seasons, which would decrease production. The tropics and subtropics are also more susceptible to drought. Another effect is that extra CO2 absorbed by crops makes them less nutritious. Additionally, intensified droughts and rainfall will cut into production. The IPCC predicts that if temperatures continue to rise, the increases in crop production in the temperate zones will not compensate for the decrease in crop production in the tropics and subtropics, ultimately causing global crop yields to decrease. This will increase hunger and famine in many developing nations. In regard to forestry, the additional CO2 in the atmosphere may spur growth, but droughts, fires, incidences of invasive species, and insect and disease outbreaks will cancel these gains. Human health is also at risk. We have already seen an increase in heat waves, and such events cause heat stress that can lead to death. As areas north of the equator warm, there will also be the expansion of tropical diseases, such as dengue fever, because the insects that carry these diseases will not be able to survive in temperate areas. Increased storm surges and flooding can spread disease and create sanitation problems. Also, flooding obviously puts people at risk for drowning. In terms of economics, food will become more expensive because the resources required to grow the food will be scarcer and the conditions to grow crops will be less supportive of high yields. A study published in 2009 reports the future prices of various agricultural products with and without climate change. Even without climate change, the price of wheat will rise 39% from $113 per metric ton to $158 per metric ton. With climate change, the price of wheat would rise 173% to at least $307 per metric ton. This will have significant and far-reaching effects on all nations. Where we live will determine how we experience the impacts of climate change. Here again we will see the dramatic difference poverty and wealth have on human survival and prosperity. The image on the right is a map showing the average temperatures across the U.S. if we pursue a course to reduce emission and what we can expect temperatures to look like if we do not reduce emissions. What is clear from this figure is that temperature increases will be much smaller if emissions are lowered. In their 2009 report, the U.S. Global Change Research Program scientists reported and predicted the following climate change impacts for the U.S. Temperature increases, 4 to 11 degrees Fahrenheit more, worse droughts and flooding, decreased crop yields, water shortages, health problems and diseases, higher sea levels, beach erosion, destroyed wetlands, drought, fire, and pests will alter forests, more grasslands and deserts, fewer forests, and undermined Alaskan buildings and roads due to melting permafrost. Temperature changes have been greatest in the Arctic. The ice sheets are melting, the ice is getting thinner, and storms are increasing in number and intensity. A NASA report came out in late October of 2015 that described that while the glaciers in the Arctic are melting rapidly, the glaciers in sea ice in the Antarctic are expanding. Some use this as an argument that global warming isn't occurring, but the flaw in that argument is that global warming is just one type of global climate change, and some areas will experience colder temperatures because of the changes in the climate. Another thought is that the additional ice in the Antarctic will offset the loss of ice in the Arctic. This is also not true because more ice is being lost in the Arctic than is developing in the Antarctic. A short video explaining the difference between how the Arctic and Antarctic are responding to climate change is also in the mini lectures, presentations, and videos for Week 11 folder. Also in this folder is a link to the NASA Global Ice Viewer webpage that allows you to explore the change in global ice over time. You can see pictures, graphs and time-lapse videos at this site. Some critics will argue that the science isn't in yet on climate change, that the scientists disagree on what the cause of climate change is, or that scientists still are unsure that it is even happening. These are all untrue. 97% of scientists agree that increased greenhouse gases are causing global warming and human activities are the cause. As was mentioned before, the two main human activities that cause increases in CO2 emissions are, first, burning fossil fuels for energy, and second, loss of carbon-absorbing vegetation due to deforestation. The figure shows the many and varied impacts we currently are experiencing and are expected to experience due to climate change. What is interesting to note is society's response to this information. Despite overwhelming evidence for climate change, many in the U.S. deny what is happening. People debate if it is real and if humans are to blame. Some think tanks and a few scientists question it. The news media presents two sides to every issue, despite the fact critics aren't equally supported by evidence. Furthermore, news media presents this issue as opinion up for debate rather than scientific fact that has thousands of peer-reviewed research studies to support it. I want to know what you think. In the Think and Group activity this week, you will have the opportunity to state what you know and believe about global climate change. But before you get to the Think and Group activities, please review the weekly outline and watch the other videos I've assigned. Then you may move on to complete the activities for this week per the schedule set forth in the outline.